Want to thank you, Jesus, that we are going to start our math lesson this morning, Father. We pray that Almighty God, may you come and be with us, Lord. May you enable us to understand, oh Jesus, whatever our teacher is going to teach us, oh Lord. May you let us be able to put everything the teacher is going to teach us in our papers that we are going to do in October, November, Jesus. May you let us understand each and everything, oh God. I've prayed all this while trusting and believing in the name of our Lord Jesus Christ. Amen.
Amen. Thank you so much for the word of prayer. Uh, and good morning once again. Today we are going to look at matrix transformations. That's where we are going to start from. Now, under matrix transformations, these are the basic things everyone needs to know. Number one, you need to know what we call transformations. Now, whenever they talk about a transformation basically means the change in either the position or the shape of an object. So here we are looking at how the shape, how the object changes. Either it can be the position or it can be its size. That's what we call the transformation. But still in this topic, you need to know the basics of matrices. You need to know how to add, multiply, and basically the subtraction of matrices. Those are the basic things you need to know. So you need your knowledge of matrices. But also we are going to look at how the area, determinant, and scale factors are related. And then lastly, we shall look at the inverse of matrices. So these are the basic things you need to know once it comes to matrix transformations. But allow me now to start with the first transformation, because we have said that transformation means either the position can change, the size can change, or we can have a shift in the position where our object is. Now, the first thing you need to know, or the first transformation we have, one, we have what we call a translation. When we talk about a translation, we mean displacement of an object from one point to another. We are looking at how an object is being displaced from one point to another. And the moment in the question you are attempting, you see the word translation. Translation means we add. So translation, the key formula here, or what you need to know is that whenever it is translation, it means that in order for us to get our image, always our image will equal to translation matrix or translation vector plus the object. That is when it comes to translation. So translation, we always add. We get the object plus the translation vector will give us always the image. That is when it comes to translation. So when you see the word translation, just know that what you are going to do, you're going to get your translation vector plus the object. You should be able to get the image. Take an example. They can give you your translation as, let me say, 1, 2, and they have given you your object maybe for you as maybe 3, 3, 2. So what you do in order for you to get the image of you, to know by how much, by what distance was this object displaced from its original position, then you'll have to just say that my image will equal to the translation, which is 1, 2, and then you add it onto your object. But you convert this object into a vector as 3, 3, 2. So this one will give us the 1 plus 3, then the 2 plus 2, and then you'll end up with here 4 and 4. Then you conclude that your image, which we always put apply, is going to be located at 4 and 4. So that is what happens in case it is a translation. Now, what about the second transformation we can have? The second transformation is what we call a reflection. Each one of us here, many times whenever you're going to move from one place to another, you look yourself into the mirror. So reflection is like looking yourself into the mirror. Now, when it comes to reflection, here, this is the second transformation we are going to look at. But what I want to first emphasize under reflection, here we are looking at a transformation where a point or where an object is mapped onto its image by a mirror. A mirror is like that same mirror you see yourself into. So that is what we call the mirror. Now, when it comes to reflection, we are going here. The major thing you need to know is where is my mirror placed? That is the most important because we have different position on how our mirror can be placed. Your mirror can be placed like this. I'm going to just shade just for clarity. Your mirror can be placed like this. And when it is placed like this, we shall say that this position or vertically like this is placed along the y axis. Then your mirror can as well be placed like this. I'm just shading, but there's no need for you to shade as long as you know. It depends where the object is. So when it is placed horizontally, this is what we call the x-axis. However, still, your mirror can be placed in another diagonal way. Your mirror can be placed like this, something like this. So this is the diagonal way. So once your mirror is placed in that format, then we shall say that this is along the line y is equal to negative x. But still, your mirror can be placed like this, something like that. So this is what we call y is equal to x. Now, these are the common forms on how the mirror can be placed when it comes to matrix transformation. So they can tell you that the mirror was placed along this axis. The mirror was placed like this and this. So you need to know how that mirror will look like. And in each of these positions on how our mirror is placed, we have a special matrix that we can derive from it. Sometimes if they don't mention y-axis, still, you know, or you know from your mathematics, this is what you call the line x is equal to 0. You know that the x-axis also is called y is equal to 0. And for this line, it can also be termed as y plus x is equal to 0. And this line here can be termed as y minus x is equal to 0. So they can bring it for you in any of those formats. Now, the next important thing is you knowing how does the matrix of transformation look like when they tell you that the mirror was placed along the y-axis. How are you going to write the matrix? We know very well that from maybe your knowledge, I'm going to write here from your knowledge, when I have my Cartesian plane, this is my Cartesian plane. And along my Cartesian plane, this is what we call the I. And at this point here, we have 1, 0. When we are deriving this matrix, the matrix, always we use a unit matrix. So that is 1, 0. This is like your x, and this is your y. And along here, we use our j, which is, this is going to be 0 and 1. So when you look at this is what we call a unit matrix or a unit square. And when you look at it, it has an area of 1. Now, when we are transforming and looking at the different reflections, we look at the different positions on how our mirror can be placed. Now, I'm going to just do for you one, and then the rest I will show you how you can generate them automatically. Take an example. Our mirror is placed along the y-axis. That means that your mirror is going to be placed like this. Something like that, that green line. That means that when you place your mirror vertically like that, like you just imagine you have stood in front of the mirror like this. This unit square you are seeing, this is our object. Now, when you stand, you expect yourself, in case this is the mirror, you expect yourself to be this side. So what will happen that this point here is going to appear this side, like here. This point here is going to appear here. So your unit square now will come like this, like this, like this. Now this I has been reflected, and this is going to be I prime. And this I prime, this coordinate, remember this is 0. So this side here, we shall have -1. So it will become -1, 0. This point along the mirror, the J, has not changed. It has remained there. So that means that when we are writing our matrix, remember, I'm going to write my I prime and I write my J prime. So my I prime here has not changed. My I prime is negative 1, 0. So in vector form, I write it as negative 1, 0. So here I write negative 1, 0. Then the J prime has remained on the mirror. So that means that its image has remained as 0 and 1. So here I'll come here and I put here, this is 0 and 1. And this is what we call the matrix of transformation whenever our mirror is placed along the y-axis. Kindly let me know through the chat whether we're on the same page. Are we on the same page? Mm. Okay. I'm going to take on one question. In case you are lost a bit, you let me know. Now here, always position yourself the way you look yourself into the mirror. That if you are here, where do you think you're going to see your image? You're going to see your image inside the mirror. And you remember the properties of a plane mirrors that for whatever position, the distance from your object to the image will always be the same. The shape will remain the same. So in case you have a question, kindly first raise your hand and then I can take on that question. Okay, now allow me now to provide the summary on how we are going to do it. Now I want you to look at my summary. Now when it comes to this matrix of reflection, you need only one matrix and the rest of the matrices, you'll be able to get them automatically. And what is that important matrix? The important matrix you need to know is the one for the y-axis here. And how is that matrix written? I want you to check how I'm going to write my y-axis. I'm going to write my y-axis like this. Hope you are not seeing. Now, when I write like this, hope you are not seeing, I'm writing my y-axis as like a negative here. To show me that when I'm deriving this matrix of the y-axis, the first digit here is always going to be a negative 1. Then this one is 0, this is 0, and this one is going to be 1. Now, the moment you know this, the rest of the matrices will be derived automatically. Now, when it comes to x-axis, it is the opposite of the y-axis. So for it, you're going to just come and say the opposite. In case this was negative, this one will be positive, this is going to be 0, this is going to be 0, and this will be negative 1. When it comes to y is equal to negative x, the moment you see that it is y is equal to negative x, it means that your y transforms into the x and the x transforms into the y, but in the negative format. So what does it mean? It means that along what you are going to have, everything is going to be negative. You have 0 here, you'll have negative 1, negative 1, and 0. When it comes to y is equal to x, those ones are always positive. You have 0, you'll have here your 1, you'll have your 1 here, and you have your 0. And that is how you can tell which matrix you have. When there is negative y is equal to negative x for diagonal lines, you'll notice that the ones are going to shift along the minor diagonal. And when it is y is equal to negative x, all of them are negative. When it is y is equal to x, all of them are positive. So along the major diagonal, everything is going to be positive. Then here, the one you need to master is along the y-axis. When the reflection is along the y-axis, that it is always the negative. Then when it comes to x-axis, you just shift. Yes. Let me know whether we are good to continue. Are we good to continue? Okay. Okay. Now that is when it comes to a reflection. Now we are going to look at the second one. The second one, okay, yes, Olive. Olive,
Yes, good morning, sir.
morning.
So there's something that I want to understand. Do you just state these things or there is where you get them from?
Oh, okay. Now, one, I derived for you the first one for y-axis. Did you see how I was deriving it?
Yes.
Yes. So that's how you derive for the rest, just because I didn't want to go through it. But in case, let me say for one of the diagonals, it means that your mirror will be like this. And now once your mirror is like that, it means that when it comes to this eye, if you remember your reflection, your eye is going to be around here. So this is going to be like your eye. When it comes to your J, you draw your perpendicular and it will drop here. So your J is going to be here. So you'll have an image of this nature. So this will be your I prime, this will be your J prime. And at this point here, we have 0, -1. At this point here, you have -1, 0. So when you get your I prime and the J prime, your I prime, here you'll have your 0, -1, and your J prime, its image is -1, 0. So that's how you derive them.
Okay, thank you so much.
Okay. Okay, so we are going to continue to the second one. Now, the second one is what we call, okay. Yes, Victoria. Victoria? Okay, I'm failing to get you. Okay, the second one is what we call a rotation. This is the third transformation we are looking at. Now, when we talk about a rotation, now a rotation means is that type of transformation whereby each point on the object is turned about a fixed point. Now that fixed point is what you call the center of rotation, and they give you the angle of rotation. Now under rotation, there are two things you need to know. One is what you call the angle of rotation and what we call the center of rotation. Where are you basing to start your rotation, and at which angle are you going to rotate? Now, under rotation, we have different ways we can rotate, but I want you to pay attention to how we rotate or to remind ourselves. One, under rotation, we look at the direction. Whenever you are moving in a given direction, the sign matters. In some directions, we shall have it as negative. In other directions, we shall have it as positive. Now, we have two movements. I can have this direction here, and this is what we call the anti-clockwise direction. Now, any angle we measure in the anti-clockwise direction are going to be positive. Because you remember very well, on our Cartesian plane, when we are measuring angles, this can be 0, this can be 90, 180. Angles go on increasing from 0 to 90. So all angles we measure in the anti-clockwise direction are positive. So whenever you find positive 90 degrees, it means that you are going to place your protractor going in the clockwise direction. That is the meaning. Then, if you have angles that you are measuring in the counter in this direction, what you call the clockwise direction, it means that all those angles are negative. Because this is 0, remember, on if at all I put my thing like this, you notice that when I'm moving this side, angles are going to be decreasing from 360 to 270 to 180. So all angles we measure in the clockwise direction are decreasing, so they are measured as negative. So the moment you find it in your question, they have put -100, it means that your measurements are going to be going in the clockwise direction. So when you are placing your protractor, you place it facing the clockwise direction. Take an example. I can give you here a simple Cartesian plane. This is our Cartesian plane. Let me say this is our center of rotation. Then this is the point we want to rotate. Now, when I join this point here, this is point A. Now, always you must ensure that your protractor is placed at the center of rotation. So I'm going to place my protractor here. Let me use this pen. So when I'm placing, I make sure that I place my protractor like this. That's how I'm going to place my protractor, such that the middle of the protractor here must be at the center of rotation. Now, when I measure the angle like this is what we call the anti-clockwise direction. So all angles we are going to measure like this are going to be positive. So here I'll come and I'll measure off my 90 degrees in case that is the rotation. However, if I was going in the other direction, then also I would have placed, this is my point A and this is my center. Now, if the angle was negative, then this is how I would have placed my protractor. I would have placed my protractor on my line like this. So the center of the protractor is always at the point of rotation. So now I'll move like this. So this is what we call the clockwise direction. So you make sure that you place your protractor in the right direction depending on the angle, on the direction they have given you, or on the sign of the angle. In case, let me say this is our Cartesian plane and we had a point, let me say around this point here, and this may be your B, and assuming that this is your center of rotation, I'll first join my center of rotation to the point I want to rotate. Then in order for me to rotate, in case let me say they have given you positive 100, positive means you are going in the anti-clockwise direction. So for that case, I would have come here. This is the center of the protractor, and I would have placed my protractor like this, such that I turn in this direction here up to when I find my 90. In case it was something like this, so here the thing you need to master is how you place your protractor. In case this was our protractor, this was our point we wanted to rotate, maybe point C, and this is our center of rotation. I'll join. Then after, I make sure I place my protractor at the center. In case they are telling me to move in the clockwise direction, then I'll come like this. Let me say this is my center of rotation. Then I'll place my protractor like this. So then I'll turn this direction here, that is the clockwise direction. Kindly let me know whether we have understood how to place the protractor when we are rotating. Have we reminded ourselves how we place the protractor? Okay, Daniel has said yes. Okay. Okay, understood. Okay, we are going to continue. So placing the protractor is going to be very, very key. Now we are going to continue to the second part. Now, the second part, or when it comes to rotation, you need to remember is that when I'm rotating, any object or any image, it means, let me just draw one Cartesian plane. Let me say this is my point, and this is my point I'm rotating. The first thing always you do, you connect your center of rotation to the point that you are rotating. So I'll always connect like this. Then after rotating, you must always come, place your protractor at the center, like we have said, and place it. Let me say it is going in the anti-clockwise direction. Now, in case they have given you an angle, let me say 120, and you come on your protractor, mark up where 120 is here. After marking it, remove your protractor. Now I'm going to remove my protractor. I'll remove my protractor. After I'm removing your protractor, what you do, you come back to the protractor and then you draw a line like this from your center of rotation. Now you measure this distance here, that in case, or you get your divider, place it from your center to where your point you want to rotate is. Let me say this is 4 centimeter. Then this line you have drawn, also you measure off 4 centimeters. So where it lands is where you have your image. So that is what now you need to remember, that the image distance, or the distance from the center of rotation to the object, is always the same distance from the center of rotation to where your image is being formed. Now we look at the matrix. Now we have what we call matrices of rotation. When it comes to matrices of rotation, what do you need to remember? Matrices of rotation, still they can be rotated depending on the direction and depending on the quadrant. The first one we have, this is going to be my first quadrant. We know very well that this is 0, this is 90. Like I've told you, when we are moving like this, we are moving in the positive direction. So when I rotate from this point and I land at this point here, I have rotated 90 degrees. And which direction? In the positive direction. So this is what we call a positive 90 degrees, or sometimes we can call it a positive quarter turn. Quarter turn. Quarter means 1 out of 4, and a turn has 360 degrees. So when you simplify, you get 90 degrees. So they can call it positive 90 degrees, or they can call it positive quarter turn, or they can just call it 90 degrees. Now, these matrices of transformations, how do they come about? Always when we are deriving these matrices, we use a unit square, which is 1, 0, and this is j, which is 0 and 1. That is a unit square. Now, when I'm rotating, I rotate individual point. What is going to happen is that when I'm going to rotate, and here always our rotation is at the origin, so I want to know that your center of rotation is always the origin. For all the matrices of transformations we derive at your level, always your center of rotation is at the origin. Now take an example. If I'm rotating 90 degrees, this point I here is going to rotate, and it will come and it will land here. So that means its image I prime is going to be at this point. And at this point, this coordinate is 0, 1. Now, when I have another point, this point J, I'm going to rotate it. For it, when I rotate it, it will come and it will land here. So that means the image of J is going to be here, which is J prime. And the coordinate at this point here, this is going to be -1, 0. You get it from your Cartesian plane that this is 1, this is 1, this is -1, and this is -1. So the coordinate here is 1, 0, the coordinate here is 0, 1, the coordinate here is -1, 0, and the coordinate here is 0, -1. Now that means that we have our image I prime and J prime. Your I prime here, we got it as 0, 1. Then the J prime, we have it as -1, 0. So that is what we call a positive quarter turn. So once they tell you to rotate, that's how you're going to rotate it. But always, we rotate this first square in the quadrant. When I am told, let me give you another one. In case I'm told to rotate, I can give you just one more. In case I'm told to rotate, remember, this is your 1, 0, this is a coordinate, this is your 0, 1, and this is our -1, 0, and this is our 0, -1. In case we are rotating still, always rotate from I, and this is our J. In case I'm rotating I, and maybe they have told us 180 degrees, this time let me put negative. It means that you are going, negative means you move in the opposite direction. So I'm going to move this I in the negative direction. So I will take this side. So when I move like this, I will land here. Those are 90 degrees. I move again, I will land here. That means for I, I'm going to land here. and this is going to be my I prime. Now, after that, I go to the J, to the object of J. I rotate it in the same direction, in the clockwise direction. So when I rotate, those are 90. I rotate again. Sorry. When I rotate, this is 90. I rotate again, 90. So this is 180. It means that now for J prime, this is going to be its position. So when I'm writing the matrix of rotation, it is going to be I prime, J prime. My I prime, it is here. I obtained it as negative 1, 0. And my J prime, I obtained it as 0, negative 1. So that is how I write that given matrix. So the angles we can rotate can be 90, can be 180. Those are the angles we usually give you, 90, 180. So when you see 0 to 70 degrees, those are the angles that are going to be common. So when you say 90, 90, sometimes this is a positive quarter turn. Like I've told you, it is 90 out of 360, which is a quarter. This is 180 out of 360, which gives you a half. This is 270 out of 360, which gives you the 3 quarters. So when they tell you a quarter turn, it means you're going to rotate 90. Half turn, you rotate 180. 3 quarters, you rotate to 70. In case you have forgotten, then do not cram. You know, a quarter turn. A turn means rotating a full circle, which is 360 degrees. Kindly let me know in the chat whether we are still on the same page. Okay, I think we are on the same page. Okay. Yeah. Now we go to the last part. Now the last part is how can we come up with these same matrices using the formula? Now why I'm showing you both approaches is that sometimes we may forget the formula on how we can come up with. And now for such cases where you have forgotten the formula, it means that if you have an idea on how they come about, then it can be easy for you to obtain it. We have what we call the general formula. And the general formula for it is given by this. The general formula, okay, let me clean this. Oh, sorry. Let me create some space here. So when it comes to the general formula, for the general formula, it is given by, those who want it, for it is always given by cos theta here. Then you'll have your negative sine theta. Then here you'll have your sine theta. And then you'll have your cos of theta. That's how the general formula is given. Now, when it is a general formula, whenever they tell you the matrix is rotated in 90 degrees, for you come here in your formula, where there is theta, you put 90. So you press cos 90, negative sine of 90, sine of 90, and cos of 90. Then you place your calculators and make sure that always your calculator is clean. So this will be 0, negative 1, this is 1, and then this is 0. So you place it like that. Okay. Yes, Regan. Okay.
Yeah,
In case, yes, okay.
teacher, I was told that that formula only works for center of enlargement 0, 0.
True, very true. Anything we are doing now, I repeat, even what we have been deriving is only when the center of rotation is 0, 0. Whenever you find these numbers that will involve calculations, just know your center will be at 0, 0. At this level, you cannot deal with a center or with a matrix of rotation whereby the center is not 0, 0. So in case you find that the center of rotation given to you is not 0, 0, then the approach you are going to use strictly is going to be the graphical approach. Hope that is okay. So you only use this approach or this matrix when the center of rotation is 0, 0. Whenever it is different, you go in for the second approach, the graphical approach. And whenever you find that they have given the center of rotation not 0, 0, what has to click into your mind is that I'm going to use now the graphical approach. Okay. Yes, I repeat, we have said clockwise. Clockwise means you are moving clockwise. This is the clockwise direction. The way the clock moves, that is always negative. When you are moving like this, that is anti-clockwise, those angles are measured positively. So even here, they can also give you, let me say they have given you 100, for you put. They have given you 90, you put 270, you put 180, you put. The beauty with the formula, it can work on any angle given. That is the beauty with it. It can work on any angle that has been given to you. But I repeat, that is only when your center of rotation is at the origin or when it is at 0, 0. Okay, that is now briefly about this kind. But also allow me to just throw a hint. In case this is our Cartesian plane, and we have been given our center, let me say they have given you center as 1, 2. Let me say 1, 2. I'm going to just estimate. This is my 1, this is 2, this is 1, this is 2. They have told that the center is 1, 2. I'll come where there is 1, and this is where there is 2. Now, this is my center of rotation. Now, in case the point I want to rotate, let me say this is the point. Let me place it here, that this is the point A. What always you do, I'm just reminding you in case I did not hint on it, join your center of rotation to the point you want to rotate first. That is the first step. The second step is you knowing which direction are you going to move. Let me say that I've given you 102 degrees. That's what you are rotating. 100, this is positive. They have not put any sign, meaning that you are going to take the anti-clockwise direction. Get your protractor. This is the protractor. Put it at the center. Your protractor must always sit at the center. After putting it there, come, put your protractor very well. When your center, that middle line is on the line, and then do your rotation. So you do your 120, that this is 0, and always do not forget that where the point you want to rotate from, here the protractor, you must always start reading from 0, and you must see the angles increasing. Do not forget that. So 1, 2 is going to be somewhere here. Then what you do, mark the point there, and then after, remove your protractor very well. Come, you draw a very long line. You draw a very long line like that, and then measure off that. In case from here, or use your divide. In case this is 3, measure off 3 centimeters here and put your A prime there. That this is my image. That is when the center is not. So the same principle applies no matter where your thing is located. Okay, in case it was the other way around, you would have placed your protractor facing downwards. And for it, you will notice the angles will be moving in that direction. Okay, now that is about matrix rotation. Then the last kind of transformation we have is what we call an enlargement. Now, when it comes to an enlargement, is that type of transformation which involves the change of the size of an object. Whenever we are talking about enlargement, we are looking at the change in the size of an object. Your object can either become big or it can become small, depending on what you are dealing with. However, here under enlargement, there are some key concepts I want you to remember. One is the center of enlargement. The center of enlargement is the basis, is where you have to stand to start to enlarge that particular object. And then 2 is what we call the scale factor. The scale factor is how big you want your object to be enlarged. What is very key here? What is very key here is you knowing how do you enlarge and what is the difference when it comes to scale factors that are positive and those that are negative. Because you can have a positive scale factor and you can have a negative scale factor. Whenever your scale factor is positive, this one means that your center of enlargement and the image formed are going to be on the same side. Whenever your scale factor is negative, it means that your center of enlargement and the image are going to be on the opposite side. That is the meaning. Take an example. If I have this point, if I have this as my object, I'm just drawing this as my object. Let me say this is A, this is B, and this is C. And they have given me my center. Let me say my center is at around this point. This is my center of enlargement. In case they give me that enlarge it by a negative 2, this means that my object and image are going to be on the opposite side of the center of enlargement. It means that if this is your center of enlargement, your object will be this side, your image is going to be this side. That is the meaning. But if it is positive, it means that if this is your center of enlargement, then your object, if this is your object and the image are going to be on the same side. This is when it is negative scale factor. They are always opposite. In case it is positive, then they are going to be on the same side. So in case this is our center and they have told us to enlarge it by negative, it means that always the first thing you do, you draw a line from the point you want to enlarge. Let me say it is A. I will draw the line like this. Like that. Then in case this is B, I'll also do the same. I draw my line passing through the center of enlargement. I do the same with point C. Now, the easiest way to do the enlargement, always first measure your distance from the center of enlargement to the point you want to enlarge. Let me say it is A. So I'll come here, I measure off here. In case this is 2, maybe 3 centimeters, but I always advise use a divider. In case this is 3, still when you are measuring, you are trying to enlarge point A, still you are going to measure 3 centimeters, but you are going to enlarge it 2 times because the scale factor is 2. So I'll come here, I start always from the center of enlargement, that this is 1, this is 2. So I'll place my point of A around here. You do the same to B, you do the same to C. So you'll find that your image is going to be this side. So that's what we call a negative when the scale factor is negative. In case, for that same case, in case this was our center of enlargement and this was our object and we have been given a positive 2, what do? This is the center. It means I will draw my line from the center up to my image. I will draw like this. I will come and I draw like this. So I start enlarging. So I first measure from the center to where my object is. But still when we are enlarging, always we start from the center. Then I will start afresh now to measure. In case say I had gotten 2, I'll measure from the center that this is 1, this is 2. So it will be here. I do the same that this is from here up to here, that this is the distance I must move. So I move 1 and then I move 2. I do the same this side, this side. So you'll find that your image is going to be this side. So that is what we call when it is positive. That when it is positive, the center, the object and image are on the same side of the center. When it is negative, they are on the opposite side. Kindly let me know whether we're on the same page. Are we on the same page? Okay. I think it is okay. Then, okay. I think we're on the same page. Then you are going to allow me to create another page, I think, and then I summarize enlargement. I summarize this enlargement. Now, the last part when it comes to this kind of enlargement, what I want you to know is that whenever your center of enlargement, whenever the center of enlargement is 0, 0, then there is a special matrix we can use whenever we are given a scale factor. So whenever you find that it is 0, 0, then this matrix here will hold, whereby K is what we call the scale factor. Take an example. Here, mainly when it comes to the calculations, always read, the moment you see that the center of enlargement is 0, 0, then that special matrix will always hold. So they can tell you that the scale factor is 3. So for you, what you do where there is K, you put 3. So your matrix will become 3, 0, 0, 3. In case they tell it is -3, then you come, you put -3, -3. Where there is K is where you substitute your scale factor. That is a simple summary on enlargement. But I repeat, whenever it comes to enlargement, you pay attention to the center of enlargement and how much are you going to enlarge. And whenever you are enlarging anything, we always start from the center of enlargement and you move. Then what can they ask again? I have seen also a mock paper that asked children to find out I saw one that was talking about a rotation, finding out the center of rotation and by how much it had rotated. I think I can run. Okay, I will show you that one. Okay, let me just show you that mock paper. Those who did CAMSA, I think you saw that item. This was the item. Yes, this was the item that was asking for that particular concept. This item here asks students find the center and the angle of rotation used to rotate the bulb from one room to another. So it means that now here you need to know when they have, because here they gave you the object and they gave you the image. So your task was to find out the center of rotation and the angle of rotation. But now, can we do this practically? Can we do this practically? If not, okay, we shall come back here. But that one I'm going to also first take you theoretically, and then we shall come back there. Now, when they give you a rotation, and they have given you the object and the image, and they want you to find the center of rotation, one idea you need to remember is what you call the perpendicular bisector. So what you do always, you always have to come, you draw your objects. Let me say this is our object, A, B, and C. And I have another object. Let me say this is my image of A prime. This is maybe B prime, and this is maybe C prime. Always what you do, in case they have told you to find a center of rotation, always join A to A prime. That is the first step. You join your A to A prime. Join object and the image. After doing so, you are going to bisect this perpendicularly. Perpendicular, it means that you bisect this line into 2 equal parts. You can get your protractor, make an arc here, get your compass, make an arc here, get your compass, make an arc. These 2 arcs you have made, you can now make your radius big, make an arc, change this side, make an arc, and then after you draw a line like this. Then after, do the same on C and C prime, then also go on and make a perpendicular bisector. Now, where those 2 lines of the perpendicular bisector meet is where your center of rotation is. After getting the center of rotation, in case you want to get the angle, then you join any of the points. You join C to the center you have obtained, join the C prime to the center you have obtained. Now, when you join, always your protractor, to get the angle, your protractor is always placed along the object line. So you'll come here, place your protractor like this. The middle of the protractor must be always at the center, and then you put it like this. And then you tell how many degrees are here, and then you look at the direction that now I'm moving in the clockwise direction, my angle will be a negative. So that is when they have given you, and they have given you to find the center of rotation. But the key idea is always join A and A prime. In case it is B and B prime, join. In case it is C and C prime, then bisect the line into two equal parts, what you call dropping the perpendicular. In case this is A and this is A prime, do not forget, get your compass. Let me say this is our compass. Make an arc here. Turn your compass this side also, make an arc. Now this arcs you have made, make your compass now still bigger, make an arc up, make an arc down, make an arc up, make an arc down, and then after you drop the perpendicular. Yes, Virginia.
Teacher, may you please repeat that one more time?
Which one
The whole
mainly?
finding the angle in general.
How to obtain the angle after drawing the perpendicular?
No, from the beginning.
From the beginning. Okay, I repeat. We have said when it comes to for finding the angle of rotation, always they'll give you the object and they are going to give you the images. They will give you, like I've showed you, that Kamsa paper. So what happens? You must always first plot. Plot your object. Let me say this is my object. Plot it. Go on and also plot the images. Let me say the images here. Plot it. Let me say this is A, this is B, this is C, this is A prime, this is B prime, this is C prime. Now, you are going to use at least two perpendicular bisectors. What do? Join A and A prime. That is the first step. Or join B, any of your choice, doesn't matter which one you have started with. So I can join A and A prime. After joining them, you are going to draw a perpendicular bisector. In other words, this line you have drawn A and A prime, you bisect it into two equal parts. What do? You get your compass, place it at point A prime, make an arc. Don't change the radius, go this side, make an arc. Then after that, you can get your compass, place it at the arc you have made, make an arc up and down. Place your compass here, make an arc up and down. Then after, you draw a line like that. And in most cases, always you can even prove that this line you have drawn leaves an equal number or leaves equal centimeters from A to where it is and from where it is to A prime. This is the first perpendicular bisector. After drawing that perpendicular bisector, you are going to go on and join any other point. Let me say you have decided to join C and C prime like that. Do the same. Draw your perpendicular bisector. Place your compass here, make an arc. Place your compass here, make an arc. Then after, you can even change the radius, make an arc up, make an arc down. Make an arc up, make an arc down. Then after, you draw another perpendicular bisector like that. Now, where the two perpendicular bisectors are meeting is where your center of rotation is. You just read off that coordinate. In case it is 0, 5, you read it the way it is. Now, after reading off this particular coordinate, to obtain the angle of rotation, you go on and look out for one point you want to use. You can decide to use A and A prime, B and B prime, C and C prime. In case you decide to use A and A prime, get this point A, the object, join it to the center you have obtained. Get this point A prime, also join it to the center you have obtained. Then after joining it, we always move from the object going towards the image. You are going to first ensure that your protractor is placed along the object line. This object line we have drawn. So I will place my protractor like that. Then I make sure my center is along this line, where I have obtained the center of the protractor is along there. Then I'll place my protractor and my protractor will be like that. So this is the center of the protractor. Then I'll come and I obtain which angle do I have on my protractor where A prime is, here where A prime is. So I read off the angle here, that this angle maybe it is 80, or it is maybe 102, or 105, or 103. I read off this angle. Then the next thing I look at is the direction. I ask myself, my object was here, my image was here. So I moved like this. Which direction was I taking? That this direction here is what we call the anti-clockwise, meaning that my angle is supposed to be positive. So I write my center is this, and my angle is 103 degrees. Hope, Virginia, we're on the same page.
Yes, teacher.
Okay, Gavanian.
Teacher, good morning.
Morning.
What if the scale factor is in fraction?
What if the scale factor is in fractions? Yes, that one is also very possible. Now, in case it is in fractions, let me give you an example. Let me say it is a quarter. What you do, this is your center of enlargement, and this is where your object is. Let me say this is A. Now, what you do for such a case, you are going to measure using your ruler. I'll first measure like this. That this is, maybe let me say it is 8 centimeters. What I'm going to do, I'll get this 8 centimeters, I multiply it times a quarter. Then those are the steps I'll move. I don't know the Gavanian, that is okay.
The 8 is just estimated.
No, like you measure from the center. Yeah, I've just estimated it. Let me say this is your center of enlargement. Are you seeing it?
Yes.
And this is your A, the point you are going to enlarge. In case from here up to here you have measured with your ruler and you have 8 centimeters, and you must enlarge by a quarter. Are you seeing? So you just multiply this a quarter times the 8. So that distance you are supposed to move, you just make it in a quarter form. So that means you just move 2 steps or 2 centimeters. That is the meaning.
Okay, thank you, sir.
Okay.
Master,
Yes, please.
another thing now, what if they haven't given you the center of enlargement? And now when you have the 3 points, can you use the 3 points to find the center of enlargement?
Okay. Now, the case you are asking is when they have given you the image and they have given you the object and they want you to find the center of enlargement. That one is also very possible. They can give you the object, they can give you the image, and they want you to find the center of enlargement. Now, for such a case, what you do is this. Let me say this is our Cartesian plane. They have given you, let me say they have given you your object. This is your object. They have gone on to give you, okay, this is, let me call that my image, and they have given me this. Let me call this A, this one, let me call this A, this is A prime, this is B prime, this is C prime, this is B, and this is C. Let me say something like that. So always what you do, in case they have told you to find a center of enlargement when you have the objects and the images, what you do, get A and A prime, join them, use a long ruler like that. Do the same to C, C to C prime, join them like that. Do the same to B prime, something like that. Now, where those lines meet is where you have your center of enlargement. Is it clear?
Yes.
Yes. Now, to obtain the scale factor, what you do, you can either measure the distance from the center of enlargement to the object. Then measure the distance from the center of the of enlargement to the image. Then you divide the center of enlargement to the image, divide by the center of enlargement to the object. You measure the distance from the center of enlargement to where your image is, divide by the distance from the center of enlargement where the object is. Alternatively, you can use the divider approach, whereby you get your divider and then ask yourself how many steps they moved to be able to reach there. That is the second alternative.
Must I measure using a ruler or just measure the number of boxes?
Now it depends. In case it is the direct, because you may have a case of this nature, whereby they are along the horizontal line. Those ones you can count the box. But in case they are diagonal, then you measure using a ruler. Fine?
Yes, sir.
Okay. Can we use, yes, Anita, you can use all the parts, It is okay. You can use all the 3 points to get the center of rotation. But as long as you have two are enough. Otherwise, you may end up wasting a lot of time and you fail to finish. How do you know where to put the object line? Can it be a decimal? Yes, it can be a decimal. But most cases, when you find yourself getting a decimal, sometimes it's because you are not accurate, but it is very possible as well. So can we now start looking at the calculations? Yeah, so I want you to first take some few minutes, read through, and then we start. First read through, and then we are going to start. Okay, when you finish read through, you let me know and then we can start. Now, after reading through, I want you now to first summarize for me 2 matrices. I want everyone to first summarize for me the reflection matrix you are going to use and the enlarged matrix you are going to use. Just summarize, then we start. Okay. Now, I think we have been able to summarize. We have been able to summarize. Now, the first thing always we are going to do, whenever you meet such scenarios, first interpret. Now, this one has 2 approaches we can use. You can use the graphical approach, but as well, you can go on and use the calculation approach. However, you need now to ask yourself, on the 2 approaches, which one will take less time for me to do it? So if you find yourself that you are going to use little time, then it is also very okay. But if you find that one approach is going to make you take a lot of time, then you go in for the easiest approach, given that you know what to do with that approach. So for this particular one, you are going to allow me to use the calculation approach. Then as part of your reading and other things, then you can go on in your free time and then you read, you use the other approach. Now, I want to let you know that the moment you see any transformation, apart from the translation, whenever you see a reflection, you see an enlargement, you see a rotation, expect yourself to multiply. And I want you to write this formula. Always that the image is always given by the matrix of transformation, times the object. So that is always the formula we are going to use. Now here we have two things we are going to identify. They have told us that he first created a mirrored version of the triangle by reflecting it along the x-axis. So that means you need to know the matrix of reflection along the x-axis. So you're going to allow me now to go to a new slide and then we start off our calculations. So when I come here, I'm going to first have my work summarized. I have my point A, which is 1, 1. I have my point B, which is 4, 1. I have my point C, which is 1 and 5. Now, how are you going to start getting the mark? They told that he first created a mirrored version by reflecting it across the x-axis. So we expect you that you are going to first write for us the matrix of reflection along the x-axis. So I'm going to say the reflection matrix along the x-axis. Remember, I told you that matrix, when it comes to the x-axis, this is the x-axis, this matrix here. And now that matrix is the matrix of this nature. I told you the moment you know the y-axis, then this one is going to be 1, 0, 0, -1. That is the first thing you write, such that you can have that mark. Now from here, we are going to continue, resulting into a new triangle, A prime, B prime, and C prime. So I'm going to write, say, coordinates of the new triangle, A prime, B prime, and C prime. So we have said that to get the images, always we say image is equal to matrix of transformation, then times the object. That is what always we say. Now, here it is up to you. You may decide to calculate at once, or you may decide to calculate an individual point. So take an example. Let me start with just one point. I'm going to first calculate for A, but then I will show you the other one of calculating everything. So in case I'm calculating the image of A prime, I'll come and say matrix of transformation is 1, 0, 0, -1, and I'm multiplying times the object of A. Object of A is 1, 1. This is a coordinate, so I write 1, 1. Now I start my multiplication. Please and please, you show how you are multiplying. Avoid assuming that people know. So I will know that I'll get my object, I'll get this, I multiply by this. So this one here, I'll multiply it with this. So I'm going to write it clear that this is 1 times 1 plus 0 times 1. Then I go to the second law. This law here, I multiply it with this. So I'll come here and I say this is 0 times 1, then plus -1 times 1. Then I'll continue and say, now this one I'm getting 1 plus 0, then 0 plus -1, which will give me 1 and -1. But this is a matrix, is not a coordinate, yet they asked for a coordinate, then I'm going to conclude and say that the coordinate or the coordinate A prime is given by 1 and negative 1. This is one way you could approach it. Now, the beauty with calculating one by one is that in case, God forbid, you make a mistake somewhere in your general calculations, here you can be bailed out. You can make it, but it is also okay. But you can, in case you do not want to waste time, you can do it at once. So let me do it at once. But I've showed you this approach. So at once, still we shall say that the image will equal to, I'll get my transformation matrix, which is 1, 0, 0, negative 1, then times the image. So the first image was 1, 1, and the next was 1, 4, 1, and I think the last one was 1, 5. This is the object for A, this is B, and this is C. This is when you are doing it at once. There is no problem. Then you start multiplying very well. You say, I'm multiplying a row by a column. So I say this is going to be 1 times 1 plus 0 times 1. Now, some of you, the problem with combining it, you may keep adding everything. Now, I'm going to the second one. Now, I'm going to go on this and this one here, up again. So here I leave some space and I write, this is 1 times 4 plus 0 times 1. Then I go to the next one, 1 times 1 plus 0 times 5. Then I go down. Now I will start the downer ones. I'll have this one here multiplied with the first one. So I'll have 0 times 1 plus negative 1 times 1, 0 times 4 plus negative 1 times 1. Then I'll have 0 times 1 plus negative 1 times 5. Then show you're working clear. So this will be 1 plus 0, 4 plus 0, 1 plus 0, 0 plus negative 1, 0 plus negative 1, 0 plus negative 5. Then from there, I'll come and say this is 1, negative 1, 4, negative 1, 1, negative 5. Then what am I going to do? I'm going to conclude that the coordinates for the first image are A prime is 1, negative 1, coordinates B is 4, negative 1, and then C prime is equal to 1, negative 5. Kindly let me know whether we are on the same page in the chat. Okay, perfect. Okay, that is good. That is good. So that's how you find for the first images. Now you're going to try for me for the second image because they told you it resulted into a new triangle. Then we continue. Then to explore variations, he took this new triangle, A prime, B prime, C prime, and enlarged it with a scale factor -2 around the center of the grid. Now, you know the grid, this is what we call the grid. This person here was lenient to tell you that it was at the origin. So you know that this is the grid and the center here is what we call the 0, 0. To get the final shape, A prime prime, B prime prime, and C double prime prime. Now, still, for you to continue, you need to know, how do I get? We say that the moment the center is at 0, 0, the matrix of transformations will hold. So our matrix of transformation, we say it is K, 0, 0, K, whereby K is your scale factor. Hope you remember that. Now, what are you going to do? Always, you're going to first come and write, say, matrix of enlargement. Matrix of enlargement. You make sure that your work is clear. Matrix of enlargement, and you put it here. Remember, your K, according to the question, was -2. So you say this is -2, 0, 0, -2. Now, this is what we call successive transformations. So because they have told that after this image, this object, this new position was the one transformed. So still you go on and say image will equal to the matrix of transformation, then times I object. So we can do it at once. In case you are not comfortable, do separated. So here I'll have negative 2, 0, 0, negative 2. Then this side I'll have my first coordinate of A, which is 1, negative 1, 4, negative 1, 1, negative 5. Remember, we are transforming this one into. So can I first leave you to everyone to calculate? Can we calculate everyone? First calculate for yourself now. First complete that matrix. Okay, some people have started to present some. Oh, okay. People have finished? Okay. 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 Oh, someone who wants to tell us what you have? Negative 8, 2. Okay. Chivumbi. Okay. Okay. Yes, Patricia? Mary?
I have for A prime
Okay, can
prime.
you first take us at least one step here?
So you multiply negative 2 times 1 plus 0 times 1 then you leave space for the next matrix, negative 2 times 4 times 0 times negative 1. Then negative 2 times 1 times 0 times 1.
0 times negative 5.
Negative, yes.
Okay, then down here.
0 times
0 times, now we are here. This and this.
0 times 1. Then negative 2 times negative 1.
Okay.
0 times 4. Negative 2 times negative 1. 0 times 1. Negative 2 times negative 5. Negative 2 plus 0 negative 8 plus 0 negative 2 plus 0 0 plus negative 2. Plus 2. Then 0 plus 2. 0 plus 10.
Yeah.
Negative 2, 2. Negative 8, 2. Negative 2, 10.
Yeah.
Now we have to present them in coordinate form. Negative 2, 2. B prime prime. Negative 8, 2. Then C prime, negative 2, 10.
Okay. Thank you, Patricia. That is correct. Now, after doing so,
Okay.
please do not forget to respond back to the question. They wanted you to hope the design to know the exact coordinates of the two images. So you can make a conclusion and say, the coordinates for the two images are, then you put those images. But when I looked through the chart, I noticed Chivombi, Alan, Shekain, I think we had the right answers. This is Regan, Timothy. I think our answers were all correct. Lenny, Renata. Yeah, our answers are very okay. Okay, now we go to the second part, part B. So here they can combine refraction and enlargement. They can combine refraction and rotation. They can combine even three. They can also go on and tell that after it was rotated about this and this. So you need to be just ready for any kind of thing they combine. Then they told that she needed to know the precise location of the corners of the transformed images and understand the overall. Now, they went on and they told us that describe a single geometric transformation. Describe a geometric transformation that would map. Now here, there are two things. They are asking, what if we had not gone through these steps of moving from A, B, C to A prime, B prime to this? How can we do it directly? Now that is where we are going to concentrate. Now, they are asking us, initially, remember we had A, B, and C. We went on and obtained our image E prime, B prime, C prime. We went on and had A prime prime, B prime prime, and C prime prime. Here we had a refraction. Here we had an enlargement. Now the question is asking, is there something we can do such that we can move directly from here up to the final answer without going through the steps, without going through a reflection and an enlargement? Is there something you can do and jump from ABC and you go to that one? Is there a matrix that can help us do that? That's what the question is asking. Now, the first one here, allow me that we obtain our first matrix here, the matrix of transformation. Allow me to call it T1. Allow me to call this one here T2. That is the second matrix of transformation we got for enlargement. Now, whenever they ask you, what is that single matrix that can move you from your object here directly to the image? I want you to pay attention here. Now, that matrix that can move you from object to the image directly is given by T2 times T1. And this one, when we are dealing with matrix transformation, this one, we read it as T1 followed by T2. It means that T1 was the first matrix that was applied, and then after T2 was applied. Please take note. Do not multiply directly T1 and T2. I repeat, when they ask us a single matrix that multiplies from object to image, we get the last matrix we multiplied times the first matrix we had. And remember, matrix transformation. You cannot interchange, you cannot what? Interchange the two. So I repeat, always get the last matrix you multiply to get the final image times the first matrix you had. Hope that is very clear. Is that okay, members? Is that very okay? Paper saying it is okay. Yeah. We shall prove it. We shall prove. Some are saying it's not yet. I repeat. When we are finding, the first matrix here was the reflection. That's what I called it T1. Then the second matrix is T2. So when you want a matrix that is going to take you directly from the object to the final answer, you always get the last matrix you multiplied times the T1. For our case, here our matrix of reflection here was 1, 0, 0, -1. Our second matrix here we had for enlargement. Here we had it as -2, 0, 0, -2. So to get that single matrix that will take us back, we are going to multiply those two matrices, but we shall start with the last transformation we did. So the last transformation we did, we are going to have it as -2, 0, 0, -2. And then we are going to multiply it with the first matrix, which was 1, 0, 0, -1. So that is the matrix we are going to multiply. So here we are going to do our multiplication. And can I first ask you also to multiply it yourself first before we do it together? Let everyone now first multiply. So everyone is multiplying. Yes, Gavania.
Answer. It is.
Okay. Take us through how you have multiplied. Take us through your first multiplication. What was it?
It is -2.
Time was?
Times 1
Plus?
plus 0 times 0. Then -2 times 0 plus 0 times -1. 0 times 1 -2 times 0. 0 times 0 -2 times -1.
Okay.
Then it's -2 plus 0. 0, 0 plus 0. 0 plus 0. Then 0 plus 2. -2, 0. 0 plus 0, 2.
Okay. Thank you. So let me hope everyone that is the matrix you have come up with. Someone is asking, teacher, what if we had three transformation matrix? Do we still use the first and the last? No. Still now there, when they are 3, you say T3, T2, T1. Like that, eh? You start with the last one, the second last one, and the first one you had. So T3, T2, T1. Hope that is okay, Mariam. I want to first respond to some questions in the chat. Chivumbi, that was okay. Martha, that was okay. Favor, that was okay. I think Renata, that is okay. I think we had the same. Jovan, I don't know where you're getting the 0. Maybe it was a typing error. Peruth, that is okay. Yeah, I think we are there. Okay. Okay. Abraham. Yes, Abraham, you may ask. Abraham. Okay, I'm failing to get you. Now, they can as well ask you, but also in your free time, you can prove it. The moment you get our first object, let me say, we said image is equal transformation times object. Chivombi, I think you were asking, even if you just do transformation times object is equal to image, it is the same. Now, when you get this transformation we have obtained, and you multiply it times the object of A, take an example, A was 1, 1. So when you put here 1, 1 and you do your multiplication, you'll find out that here you get -2 and here you'll get 2, which is the same thing we had at the end of A prime prime, -2 and 2. That is what I wanted to bring to your attention. The moment you get this matrix and multiply it with ABC, you get back the exact answer. Now, this time round, they asked us to move from ABC to this. Next time, they may ask you, which matrix they can use the word undo. A double prime, B double prime, C double prime. It can come like that. That which matrix can undo A prime prime, B prime prime, C prime prime to get the original object. Now, that means this time round, you are moving from this coming back here. That is the meaning. Now, for such a case, what do you do? Still now, that one, you only go on and obtain the inverse of this. Is that clear? You obtain the inverse of T2, T1. You obtain the inverse. You first obtain this. You first obtain the matrix that takes you directly. Now, to take you back or to undo, you just get the inverse. So, for such a case, what you do, in case they had asked that what matrix can undo A prime prime, B prime, C prime to get back the original thing, you'd have gone and obtained the inverse of this matrix. So you just come here, obtain the inverse. Hope you remember how to get the inverse. Can we just add that question? Let's just add maybe a part there. Find a single matrix. Find a single matrix transformation. I'm just adding this question. Transformation that can undo, sometimes they can say that can take you back from undo A prime prime, B prime prime, C prime prime to obtain or to obtain the original object. So we have said what you do. You first get what takes you directly, then you get its inverse. So if you remember how to get the inverse, let's get the inverse of that. So we said inverse. I expect you to know that to obtain the inverse, you must have the adjoint and you divide it by the determinant. So our adjoint means the change in the positions. So I'll come here and say the adjoint of our matrix here, you only interchange these ones, the position. So this will be 2, this will be -2. Then these ones here, you change their signs. So it remains 0, 0. I don't know that that is what you have. What do you have? Yes, Regan, that is okay. Regan, that is very okay. That is very okay. That is very okay. Always you get the last matrix times the first one. That is when you are going directly. That's when you are going directly. So can we first get your answer? Get your answer. And then we are going to continue. I want everyone to first get the answer. Obtain the determinant. So adjoint, interchange the position. Then what are you getting for determinant? Determinant, you know, we say you get the major diagonal elements. Chivombi, thank you. You get the major diagonal elements. People are getting Angel. I'm getting -4 Angel. Shifa is getting -4 Angel. You can check out favor, that is okay. Then after you divide, so we shall divide every element by -4. So you divide 2 by -4, 0 by -4, 0 by -4, and -2 by -4. So at the end of that day, you'll end up with -1/2, 0, 0, and this one is +1/2. So that's how you find such. So the moment you get this matrix and multiply it, you'll find yourself going back to the original thing you had. So that is when, in case they ask you how to undo. Okay. Okay, members, you can let me know whether we are on the same page. Are we on the same page? Okay. We are going now to continue. We have not yet finished the question. We are going back to the question. Then the last question. The last question asked us that determine the amount of money the designer will get from the image triangle A double prime, B double prime, C double prime. Now, what do you need to remember? They have told that the cost of this design per square centimeter. Now, the moment you see square per square centimeter, that is like centimeters squared. Per square centimeter, this one should give you a knowledge of area. That here they are indirectly asking you, what is the area of that particular triangle you have obtained? Now you ask yourself, would you need now to draw again? No. Now, what are you going to do? I'm going to come here. This is my new board. Now, remember, when you look at the question, they wanted you, when you look at it, they wanted you to get the amount of money the designer will get from the image triangle, A double prime, B double prime, C double prime. Meaning that the interest is in obtaining the area of the final image. Now, which coordinates did we have? Now, the coordinates we had for the image area A double prime prime, we had -2, 2. We had our B prime prime as -8 and 2. And then we had our C prime prime as -2 and 10. Now, I'm going to show you one approach you can use, and then later on for you can discover other approaches. Now, one approach we are going to use the determinant approach of finding the area. Whenever you have a triangle and this triangle has coordinates, we can obtain or we can use this approach. Now, this approach, we say that the area of the triangle is given by 1/2. This one is magnitude. Magnitude means that we don't want a negative. You say A1 minus A2. whereby A1 is referring to that area along the major diagonal, and then A2 can be that area along the minor diagonal. But that is the multiplication of elements along the major and elements along the minor. What do you do? When you look at this triangle, roughly, let me draw it for you here. This is A prime prime, this is B prime prime, and this is C prime prime. So what do you do? I'm going to arrange. So you check out how I'm arranging. I'm going to start with A prime prime. So when I start with A prime prime, I have negative 2, 2. Then I'm going to go to B prime prime. So this is B prime prime, which is negative 8, 2. From B prime prime, I come to C prime prime, C prime prime, which is negative 2 and 10. Then I cross my triangle from where I started from. So I'll have A prime prime, which is going to be, my point A was negative 2 and 2. It does not matter. Another person can decide to start from B to 2. It is also okay. When you start with B to 2, you write B prime prime is negative 8, 2. It is okay which any direction you move. In case you want A, you go this side, A prime prime, which is negative 2, 2. From A prime prime, come to C prime prime, which is negative 2 and 10, and then come back and cross at B prime prime, which is negative 8, 2. The thing is, what you start with should be the same thing to end with. Now, after that point, we are going to get our A1, this A1 here. Now, to obtain A1, you are going to multiply the elements along the major diagonal. You are going to multiply here, multiply, hope you are noticing, multiply here and multiply here. So I'm going to come here and I say, my A1 is going to be negative 2 times 2 plus negative 8 times 10 plus negative 2 times 2. So this will give us negative 4 plus negative 80 plus negative 4. And this one will give us, is this negative 88? Yes. Then to obtain A2, I'm going now to work with the minor diagonal. Now the minor diagonal, I'm going to have this. I'll multiply this in that order and also multiply that. So A2 is going to be 2 times negative 8 plus 2 times negative 2 plus negative 2 times 10. So this will give us negative 16 plus negative 4 plus negative 20. So when you add 16 and 4, this is 20 plus 20, which gives us negative 40. Now after that, but let me first check whether we're on the same page. Are we on the same page? Are we on the same page? Megan says yes. Proscovia, no, no. Yes. Now, I know some of you have not seen this somewhere, but you follow through such that you can also learn this technique. Not yet. No. Okay, I'm going to repeat. Let's complete. Now, when you reach here, we shall substitute our A1 and A2. So this will be a half. You put your magnitude. So here, our A1, we used negative 88 minus the negative 40. So this will give us a half magnitude, negative 88 minus 40. That will give us negative 48. But the use of this magnitude is to absorb this negative. So I'm going to throw out the negative and I see this as a half times the 48, and I will end up with 24 as my area. And these are square centimeters. That means that the area of square centimeters, like the way they gave it to us in the question. Then after here, but let me first take on any question. In case you have any question, you can ask. Let me start with Joel. Yes, Joel.
Excuse me, teacher. Good morning.
Morning.
Good morning, teacher.
Morning.
I wanted to ask that, is it a must that you must have a direction?
A direction. No, any direction you take is okay. As long as what you started with is what you end with, you'll get the same answer.
Okay, so the magnitude absorbs the negative sign.
Perfect. Perfect.
Okay. Thank you,
Okay.
teacher.
Okay. Uh-huh. Natal,
Good morning, sir.
morning.
I was wondering how you obtained the coordinates that you are multiplying. I did not understand.
Okay,
How
now
you
Natal,
multiplied.
Natal, you first stay on, eh? Natal, from our
Yes, sir.
first part A, from point A, from our first part of the task. Are you seeing?
Yes, sir.
We obtain the first one, we obtain our A prime here, and then also we obtain the second A prime primes here.
Yes, sir.
So we are picking them from here, since that's the area they are interested in.
Oh, okay, sir.
Okay. Richard? Richard? Oh, Richard is not unmuting. Gavanian?
Master,
Yes.
why did you eliminate the negatives?
The negative, because we do not want to have an area that is negative.
Then how did it disappear?
Yes? No,
How
because
did
are you
it?
seeing the magnitude? The magnitude absorbs the negative. In other words, I didn't want to go into the mathematics of saying x squared plus y squared. Now, since here we have 1, this becomes negative 48 squared plus the 0 squared, which gives us the negative squared. That remains still 48 squared. Then the 2 cancels and you get 48.
Okay,
But that is how it comes about.
thanks.
Okay. Okay. Richard? Okay. Okay. Yes. Now, for whatever coordinates you use, as long as you fall through very well, you'll get the same answer. Now, the task, they told us we have not yet responded to the task. So the task wanted us to find the amount of money the designer will get from the image triangle. So here, remember, each square meter was for 240. So we are going to use that. So can you first go on and continue? Yes, Favor.
Okay, good morning, sir.
Morning.
Before you continue to the next part, like you said, some of us have never seen this. So I was just requesting you to repeat, like after getting these coordinates, the A prime, I want to know why it is again the A prime, like 1, which is equal to the A prime prime, that stuff. I don't get. Yeah,
Okay.
so I was just
First
requesting
come
you to
again, first come again.
like after listing the coordinates of A prime prime, this other step where we have the first A, like down here. I want to know like what exactly has happened there.
Oh, here. Now here we are multiplying the elements along one of the diagonals. So we are multiplying, we started with the major, so we are multiplying these elements here. Then we are multiplying these ones here and these ones here.
Okay.
Have you seen?
Yes.
Then from there, we are going to go on and now multiply these ones here along this minor one, along the minor one, along the minor one.
Okay, sir.
Is it clear
Thank
now?
you. Yes.
Yes. So as long as you are dealing with, please, and this one only works on a triangle. In case it is any other figure, it will not work. And it works when you have coordinates. Here, another alternate, the other second approach you could use, those who are interested, you could find the length from here up to here, find the length from here up to here, find the length from here up to here. And then from there, you apply the Heron's formula. That one can as well work, in case you know it. Double. Double.
Hello.
Yes.
Excuse me, sir. I have a problem on this. Are we multiplying? Are we dealing with matrices or
Which one?
this
Here.
number? Are we dealing with
Oh, okay, I didn't pick you well, but we are looking at how can we obtain the area. How can? Yes, that's what we are looking for. But I know, I'll check out. I think there is a video I made about this thing of finding the area. Maybe I'll share that video such that you can be able to understand further and look at different examples. Yes, Joel.
Um, Again, one more time here, the second last step. How did you remove that? How did you remove the negative? Because I'm seeing I have
Here.
this. Yes.
Oh, now,
So
Joel, the moment,
yes.
the moment you find yourself having magnitude like this, and there is a negative, this negative is always taken away by the magnitude. They absorb it. So in other words, when I have negative 48 in magnitude, this means get the square root of x squared plus y squared, which is the same as negative 48 squared plus, now the y component is 0 for such a case. So here you'll have the square root of negative 48, everything squared. But you know very well that negative 48 squared means negative 48 times negative 48. So negative times negative is positive. So then you'll have 48 times 48. But I've not forgotten the root. There was a root here. So 48 times 48, and you get a square root, still remain with 48. But what is important, your area can't be a negative. That's what I want now you to know. Your area can't be a negative. That negative is taken away.
Okay, thank you.
Okay. Okay. Hope that is very, very okay. Okay. Are we there? Kindly let me know whether we have picked something. What is Heron's formula? Oh, Heron's formula. Okay, okay, okay. Somehow. Yes, but I'm going to share that video when I made something about it. Yes, I'll share video. Now, Heron's formula, I'm just giving just for your own now Heron's formula, whenever you want to obtain the area of any triangle, you can use it. And now for that one is always given by this s into s minus a, s minus b, s minus c, whereby s stands for a plus b plus c out of 2. Now, this one requires you to find the length between the two sides. Take an example. This is a prime prime. This is negative 2 and 2. This is b prime prime, which is negative 8, 2. So you find the length, the distance between a prime prime and b prime prime. So you remember how to find your distance. Oh, I don't know whether you remember. It was something like this. x2 minus x1 squared plus y2 minus y1 squared from your geometry, from that mathematics. Then you get the length here, get the length here, get the length here. After getting the length of the three sides, then you substitute. You say A is one of the sides, B is another side, and C is another length. You add them, divide by 2, and substitute here. You get the same answer. So heron was an engineer who discovered it. That's why we call it the heron's formula. But that one is just for you, for just. I'm not. Okay, last one, Mugisa Olive.
Excuse me, sir.
Yes.
For example, if I want to find the area of that part, after obtaining the coordinates that I'm going to use to find the area, what if I first plot those coordinates on a Cartesian plane, then I find the distances?
It is okay. But now here, I want you to always look at the time you have. The time you are going to take to plot, find a distance is a little much. So you need to balance things well.
Okay.
So it is the time that can limit you. Fine? Okay.
I think Edoni's formula is simple.
It's simple.
Mm.
Yeah, so it is up to you. It is up to you.
Because we are the only solution we are having, the only problem we are having this time, how to balance time or to manage time during the examination time.
Yes.
Is the problem now.
Okay. Chivumbi wanted to throw some light. Okay. So let me hope here members have been able to multiply the 24 times the 240 per square, and then you had 5760 as your amount. So you conclude for that amount. Okay. Let me hope
Excuse me, sir.
Yes, please.
Assist us to show us the question, because some of us we came a little bit late, but we are sorry for that. But yes, we need to see the question.
Okay.
Okay,
Yeah.
thank you.
All right. So let me take you back to the question. Now, on this same question, they can as well ask other questions. Yes, they can ask other questions. Now, I want to transform this question. And then it is the question I want you to try out. So allow me to transform it, and then you are going to just change, and then I want you to try it out. So I want to say it took the...
Now.
Not now. I'm just transforming it, and I want people to try it out. So you are going to just change for me a few things. No. Okay. Just take a screenshot. Let me transform another question that people are going to try out in their free time. Okay, I've moved on. Now, for this one, okay, I'm going to transform it. Allow me to transform it. As I'm transforming it, I want you to allow me to first move. So I want you to write I'm transforming this. So okay. Yes, but I want you to use calculations, eh? Sorry. So you may take a screenshot of the question. Yes, I want you to use your knowledge. Can I add? I think I need to add some kind of rotation as well. But we shall look at rotation maybe. But take a screenshot. You are using calculation. Okay. Okay, let me hope you are finished to take a screenshot. So, I think it's already 7. Thank you so much for attending. Now, tomorrow we are going to continue with transformations. Now, but tomorrow we are going to look at the graphical approach. We are going to look at different scenarios that involve the graphical approach. But I can give you some and you start, okay. Yeah, but those who have CAMSA, you can look at CAMSA. I have some here that we shall look at tomorrow, but just keep time. The lessons start at exactly 5 on my watch here on my clock. So as long as it's 5, we shall always start. Yes. Yes, Abraham and then Hope.
Excuse me, sir. I was inquiring for the matrix of A equal to X.
Hope? You were?
I would like to ask that what if I'm given
Oh,
the question
I've
comes
failed to get you. Yes, Hope and then
My
Favor.
question is, what if you are given the triangle and they tell that it was enlarged about the center,
Was
but you're
enlarged
given only
by?
the scale factor?
They tell it was?
The triangle was enlarged about the center and you're given the scale factor. Which general
Oh.
formula can we use?
About now, if it is enlarged and it is at the origin, then the formula, the matrix is that one of K0, 0K, as long as the center is at the origin.
But when you're not given the center, they just tell you about the center and they give you the
About the
scale
center.
factor.
And the center is not
Yes.
0, 0, eh?
Yes.
And then that one you use the graphical approach.
Okay.
Yes, Favor?
I just wanted to say a closing prayer if everyone is done asking questions.
Okay, let me take on Hope. Okay, Favor, you can lead us in a word of prayer.
Okay, let's humble ourselves
Hey,
and
a
pray.
minute. Okay, Favor, I'm going to
Yes.
ask people to put in the chat. I have started uploading for you different items. Let me say item 1 for order mocks. You can specify for me which items you want me to, or like topics, for those different items for the different mock papers you want. Okay, Favor, you can continue.
Heavenly Father, we thank you for today. We thank you for the gift of life and for our morning lesson. We thank you for enabled our teacher to teach us, O Lord Jesus, and we pray that whatever he has taught us, that we shall not forget and keep practicing. We pray that by the time your name comes, King of Glory, we shall be able to face it. And we pray, O Lord Jesus, that you keep blessing us, bless our teacher, keep giving him strength, bless us throughout the whole day, bless all the programs you're going to have. In Jesus' name we are prayed and believed. Amen.
Okay, thank you, Favor, and thank you, everyone. Let's meet tomorrow. And today, those that are attending the history lesson, keep time. It will start at exactly 2 and it will be for 1 hour. Then on Saturday, we shall also have a history seminar on this Saturday. It will start at 9. Thank you and bye.